Yeah, so the if-else. When you have a series of if statements, they're not mutually exclusive. Now, with if and else, you have this either-or operation. If some condition, do this, otherwise do that. One of those two blocks is going to run when you have if and else. So if I scroll up, I'll remind you what I mean. See? Like smush, right? Remember smush, if it was positive, return half the number, otherwise return the number. So here it is with if and else. If a number is greater than 0, you do that, otherwise you do the other. One of those two is going to run. There's no way neither are going to run, unless the program crashes before somehow. When this function runs, one of those two blocks is going to run. One, at least one, only one. One, but only one will run. They're mutually exclusive. But if you just have a series of if statements, you won't have mutual exclusive operation, like execution, functionality. What I mean is, in this example, if I said, what was the example I actually provided here? I think, if I put in 99, what I want to happen is, well, that's an A+. If you got 99%, that's an A+. But what would happen here is we would see D get returned, the string D. And if you're wondering why, there's one way to find out. What does the code say? Make no assumptions, do every line. I don't care how silly it feels. That is what the professionals do. That's what the people paid the big bucks do. So don't expect to somehow magically skip some steps that they're doing. What does the code say? All right, if I call this function %grade 99, is 99 greater than or equal to 90? True. Who said yes? Someone said yes.
It was me, but I switched.
You fixed it. Okay. All right, good. So true. Great. So that means letter grade is assigned to A+. Then I go down to the next if, because a series of ifs are not mutually exclusive. They're just a series of if statements. So I ask the question, okay, is %grade greater than or equal to 80? Is 99 greater than or equal to 80?
True.
Yeah, all right, so it's set to A. Then I ask, is it greater than or equal to 70? True. So it gets set to B. Is it greater than or equal to 60? True. It's a C. Greater than or equal to 50? True. So it gets set to D. But that last if-else is mutually exclusive. So because we ran that last if, that else doesn't run. So finally, the value letter grade has is D, and we return letter grade. So this function gives me back the letter D, which is, of course, not correct. That's not what we want. There are a number of ways to fix this. Another example of, there are a lot of ways. There are literally an infinite number of ways. I'm not joking. There are literally an infinite number of ways to solve a problem like this. There are a lot, okay? And a lot of them are fairly intuitive to you. So half the people in the room might think of doing it one way, another half might think of another way. Who here thinks, well, what I could do is do like, check that it's greater than 90, or greater than 80, but less than 90, right? Who here would think, like, if I do an and, check two conditions. Don't just check that it's greater than or equal to 80, check that it's greater than or equal to 80, but less than 90. Who here likes that solution? Raise your hand. There, a good chunk of you. That is one way to solve it. Another way is with the use of else ifs, which is just a way of saying else if, elif is else if. So it's a way to now make that block of if statements mutually exclusive. Only one will ever run. As soon as one runs, the rest are skipped. So in this way, where it's written this way, if I check if 99 is greater than or equal to 90, it's true. It runs letter grade equals A+, great. And then because there's all those elifs, followed by an else at the very end, you want an else at the end, it's kind of that catch-all. All of those are skipped. If they were regular old ifs, each would be evaluated. But because they're elifs, it'll only look to run one in that whole block of if statements. Else if statements. So that is another way to solve it. Who here likes this solution? Yeah. The other half of people, great. Or maybe you liked both, whatever. I did notice some people in lab who didn't know this syntax. They wrote else, indented, if, condition. And then they would go in and have an else, and then indented. So they ended up having this chain of indentations. It looked kind of crazy, but it would work. Who here did that? I saw a couple people in lab do it. So one person, two people, entirely workable. But of course, it was kind of clunky, right? It was cumbersome. You had all these indents, multiple lines, felt maybe a little redundant. So this is where that syntactical sugar idea pops up, where, well, we've got a nice way to simplify that logic in our syntax. Same idea, just now you have less indentation, less writing. There's nothing stopping you from nesting if conditions. So here's like a quadrant checker. Remember learning your Cartesian plane? Which quadrant is it in? Are x and y both positive? Is one negative and one positive? Are they both negative? You know. Which quadrant? Well, here's some code to check. If x is greater than 0, then you indent, and then you check if y is greater than 0, well, it must be first quadrant. If y is not greater than 0, but x is greater than 0, because we're in that if block, then we must be in the fourth quadrant, else, and so on. This is entirely reasonable. You can nest if statements inside each other forever. Don't. If you do, you're probably doing something wrong. But maybe you don't like that way. Maybe the use of and is a little nicer for you. This with the and this with the nested ifs are functionally equivalent, but they're just done a little bit different. Maybe you like it with the and, maybe you don't. Both are fine. Questions about any of that? Raise your hand if you're like, I'm not too clear on this. Be honest. Okay, so I assume everyone understands this entirely. Because as soon as we go into this if, and then we are on this, in this chunk of code, this condition must have been true, meaning for either of these, I know x is greater than 0. Cool. All right, great. All right, so far we've actually seen a hell of a lot. We talked about values, we talked about types, values have types, variables and literals, print, input, so a way to like output information, a way to get information, functions, booleans, logic, and then if else, like we call those conditionals sometimes. That's a lot we've learned. And at this point, at the first chunk of the class, a lot of it is I'm just throwing information at you. I'm giving you tools to add to your tool belt. But just knowing how to use each and every individual tool on their own is not very helpful. That is the easy part. That's the simple part, perhaps is a better way to word it. Where complexity arises is when you need to use these tools in different ways together to solve more complex problems. It's that same idea. Who here knows how to use a hammer? Who here knows how to use a saw, a screwdriver, and so on? You know how to use all those tools, but do you know how to use all those tools to build a whole house? There's a big difference. There's a big jump between the two. Each thing may feel simple on their own, but putting together is difficult. So when it comes to writing bigger programs, we've got a bigger problem to solve, a more complex problem we need to solve. Chances are our programs are going to grow in complexity as well. This is normal. There is no right way to go about solving a problem. Just like there's no right way, there's no one right way to write a function to solve a problem. There's literally an infinite number of ways. But there's no right way to go about starting to think about how to solve the problem. You are given a problem, here, solve it. Okay, if your brain goes straight to what code do I write, you're not doing it right. What you're supposed to do when you get a problem is you think, what is it asking me to do? What is the problem? And what are the general ideas of what I'm going to need to do to solve that problem? This idea is going to become more and more obvious as we go in the course, because the complexity of the problems are going to grow and grow and grow. At this stage, maybe the thinking of what's the solution and what the explicit code is very similar. But as we go, it's going to grow in complexity. So you need to know how you want to solve the problem before you can start writing any code. See a couple people at the back without masks. Put them on or go get one. So there's no right way to start solving a problem. There are strategies, and developing this, like it's more of an art than a science. Developing this is something that you would be doing over your careers. People who've been doing this for decades are still developing this skill. For now, we're going to talk a bottom-up incremental approach. Bottom-up only really works for us at this stage because I'm introducing the problems in such a way where it's like, okay, do this, and then use that to solve this problem, and use that to solve this problem. That's a bottom-up approach. We kind of start at the basic thing and then build our way to complexity. In reality, that doesn't work. That's not how any problem you're going to come across in real life, in the wild, that you're not going to be able to do that. You have to start with what's the problem. I need to break the problem down into bits, break those problems into smaller bits, figure out how to solve those smaller bits, implement those smaller bits, use the smaller bits to start. So you got to go all the way down before you can start building your solution from the bottom up. So that'd be a top-down approach. But right now we can do bottom up because we're just learning and starting. We always want to do very incremental approaches to our solutions. Never write your whole program and then hit run and then go, oh, it's not working. It's not going to work. I guarantee you, unless you are writing a one-line function or something, you're not going to sit down and write your whole solution in one go, hit run, and everything's going to work. That'll never happen. What you got to do is, okay, I need to write a function to do this. Okay, the first thing the function needs to do is do this calculation. So I'm going to write that line of code, and I'm just going to print the output, print the result, just to make sure it seems to be working correctly. You do it, okay, I know that part works. Great, so now I can add more complexity, check that it works. Add more complexity, check that it works. Very incremental, and we want to test and check correctness as we go. Because as soon as you find a problem, well, chances are that problem is introduced in that last increment you added. Where if you wrote a whole bunch of lines of code, you hit run and it doesn't work, where's the issue? You wrote 50 lines of code, good luck. So start with an empty function. Have it return something arbitrary, I don't know, like 0. Great. That might feel silly. Seriously, that's a great place to start though, because it forces you to name your function and think about what parameters you need. That's a huge part of this. Run the function, verify it does what you expected. If it's returning 0, it better return 0. Add 1 or 2 lines of code. Maybe it takes the parameters and it adds them together. Maybe your function needs that to happen. Okay, write the line of code to do that. And then just to make sure it's working properly, add a little print there to print out the value that you just calculated. You're going to delete that print eventually. It's only there for testing purposes. Repeat. Add a little bit more, check that it works. Add a little bit more, check that it works. This incremental strategy is great because a lot of problems you're going to be doing are incremental anyways, and it helps ensure everything's working along the way. If everything was working, you add 2 lines of code and suddenly it stops working, where's the problem? Probably in those 2 lines of code. So let's say we've got a car rental problem. Here, we've got a bigger problem than we're used to. Everything so far has been write a function and go do this. Now we've got a car rental problem. But we're going to follow the incremental approach, and we're going to take it to a big extreme. We're going to break this down a lot. Instead of just writing 1 line at a time and testing it, which we can do, but we'll also write functions at a time and make sure everything's working right. So here's the problem. I'm going to just read what it says. A car rental place needs our help. They want a program to calculate how much a customer is to be charged based on their rental agreement, age, how far they drove, and how long they had the car. we will get and record the customer's age, rental agreement classification, B or D, number of days rented, starting odometer reading, ending odometer reading. If it's classification B, they're charged 20 bucks a day plus 30 cents for every kilometer driven. Classification D, they're charged 50 bucks a day, but 30 cents for every kilometer driven above the 100 kilometer a day average allowance. That seems like a beefy statement, but we're going to think about it, talk about it, and break it down. All renters under the age of 25 are charged an additional $10 a day because rental places are terrible. So, what do? Well, read and understand the problem. You can't start solving if you don't know what it is. Part 2. Okay, yeah, understand the problem. Cannot be understated. This is a big part of solving any problem. If you are starting an assignment and you read it and you're like, well, I don't know what I'm supposed to do. How am I supposed to do it? You need to understand, taking the time to think about what the problem is a huge part of your job. That is a significant part of the assignment. That's not the thing you need to have before you can start the assignment. No, that's the start of the assignment, reading it and understanding it. If you read it once and don't understand it, you're normal. You shouldn't expect to. If you read it once and you come to my office freaking out, I don't understand what it is, I don't know, what am I going to do? I mean, we can talk about it, but you're not supposed to understand it after the first read through. You're supposed to take your time with it. Think about it. That's step 1, or step 2 as I have it here. So let's think about this problem. Look. All of this, age, rental agreement, number of days rented, starting odometer, ending odometer, that's all like input. And then we're going to return the final charge. That's all I/O. We know how to do input and output. Input, you use the input function, which we're going to use in this example, but typically we don't really use very often. And print, to print output. You got a question or just a stretch? Stretch. So we know how to do the I/O. We know how to read the age. We can read starting odometer reading and whatnot. So we know how to do this. We can start here. The other half of the description is the calculation, is this part. If they rented it, let's put it this way. If they rented it for 10 days, they would be charged $200 based on the amount of days if they had classification code B, right? $200, and let's say they drove it 100 kilometers. Well, that'd be another $30, right? Because it's 30 cents for every kilometer. 30 times 100 is 0.3 times 100 is 30, right? Just move it 0 over twice. Great. So that would be 30 plus 200. All right, 230. Like that's all the calculation is for B. So B is not too bad. If the rental agreement was B. We're going to read the rental agreement. If it's D, it's a little bit different. So let's say they're rented for 10 days. What's the base charge of per day total? 10 days, 50 bucks a day. What is it? Wake up. 500. Great. You can multiply by 10. Now this is the weird one, right? Oops. 30 cents for every kilometer driven above the 100 kilometer a day average allowance. Okay, so what the hell does this mean? Let's think about it. Raise your hand if it's not immediately clear. That's a little like, what? Yeah, it is. So let's break it down. Okay, so 30 cents for every kilometer driven. All right, that part's not too bad. For 30 cents for every kilometer driven. But we've got that fancy little condition there. It's only on the number of kilometers driven above the 100 kilometer day average allowance. So it looks like with this rental agreement, what it is for 50 bucks, you get the car and you are not charged for any kilometer unless, if I rented it for 1 day, unless you drive over 100 kilometers. If you drive 101 kilometers, you're charged for that 1 extra kilometer. If you rented it for 2 days, all right, so if you drove it 200 kilometers or less, you're not charged anything extra because you get 100K a day. But if you drove it 201 kilometers, well, you got to pay for that extra kilometer. Great. So that's the idea here. Taking the time to understand what the hell that means is a big part of your job. It's not something that's supposed to be immediately clear, and it's not something you need to know before you can start. It's where you start. Understanding it is where you start. Okay, great. Chip away at the problem. All right. Understand that the above, or the example below, is only one possible implementation. Yes. So here, look at this. Here is some code to start solving this problem. And you'll note that this is all the I/O. First line is read their age, convert it to an int. Presumably we want their age to be an integer. Classification, that we can keep as a string because it's either going to be B or D. And for simplicity, we'll just assume that they give a B or D. If I input like an F, well, that's the user's fault, not the program's fault at this stage. Number of days, well, that's just read the number of days. Starting kilometers and ending kilometers, great. In fact, I can already start to see, if I know starting and ending kilometer, like the odometer readings, how can I calculate the total? It's just the difference between the two. So we're already taking a step there. If I want to know how many kilometers they drove on average above the 100 kilometer day limit, well, I can take the difference and I can start thinking of doing the division by the number of days. I mean, there's a lot going on, but you know what? Let's slow down. I'm getting ahead of myself. In the above example, we would want to verify it's doing what we expect, since user input is a little difficult to test with assert. That's another thing. Input is really problematic to do tests with, like our assert tests. So for our purposes here, we're going to have to do an eyeball test, which is you hit run, you look at what the result is, and you're going to have to confirm with yourself what you expect to see. The easy thing here is to just print out the value and its type, because that's what this code is doing so far. Read input, what did you read? What's its type? That's what matters right now. That's difficult to do with the asserts. Yeah, okay. If we go up here, all of this is I/O. The only thing here is line 7, where I'm calculating the total charge based on some function to do the total charge calculation. We don't have that. I mean, that's a big gap. But would you agree that, imagine I have this magic function that exists. We have to write it, but let's pretend it exists. And I call it by saying total charge equals the magic function. And that magic function gives the right value. I print out the total value at the end. That's a solution to the problem. Obviously, there's a giant gap. We don't have that magic function, but if we did, this would be right. Read the input, call the function, get the result, print the output. That's a solution, right? So we actually have to now think about, well, what's in that magic function? Okay. Well, let's think. Calculate total charge is going to be the name of my function. It's going to take some number of parameters. I don't know. That's just standing parameter value, if it wasn't obvious. What parameters am I going to take? I don't know. We'll think about that as we go. But what do we need this function to do? Well, we want to calculate the total charge. We're going to want to know the total number of kilometers driven. We want to calculate the average number of kilometers driven. Calculate the charge. Oh, here we got if it's a rental code B, we need to do a special charge, which is I got it in the comment there. 20 bucks a day plus 30 cents for every kilometer driven. Otherwise, it's the 50 bucks a day plus 30 cents for every, that's just from the description. And then there's a little more down here. If they're under 25, additional charge. So we could have an if statement there to add to the additional charge. Return sum total charge. Great. So what you see me doing here is obviously I just have a variable equals nothing, except for the first one where it equals 0. Great. Everything else is just basically blank lines. But by doing so, I've kind of laid out what my function needs to do. So if I need to calculate the total kilometers driven, based on the way I started to outline this program, let's go. Okay, so although it may feel like it's a rather silly function so far, it did help us outline what we need to do. We need to know the total kilometers traveled. We need to know the average kilometers a day. We need to know the number of kilometers driven above the 100 kilometer day average allowance, assuming it's travel, or it's agreement D or whatever it was called. We need to do the actual rental agreement classification calculation. We need to add the extra charge for people under 25. Okay. So total kilometers. Let's write a function to do that. Great. Total kilometers is the name of the function. It takes two parameters. Odometer start, odometer finish. They're both floats, and it's going to give me back a float. You read the description, and all it does is return the difference. That's it. There should be nothing about this function that scares you. And I've got a couple of cert tests down there, just to make sure it's functioning correctly. You may think, isn't it a little silly to do a function for that? It's just the difference. Raise your hand if you kind of think like, you know, I probably wouldn't have made a function. I would have just calculated the difference in the other function. Yeah, a couple people. Yeah, entirely reasonable. Great, makes sense. Sure, you could look at total kilometers and make an argument that, like, you know, total kilometers traveled equals the function call, perhaps a little more descriptive. But if I had good parameters, I could probably just take the difference, odometer readings, and get a sense of what it is. But whatever, I wrote it as a function. And functions are nice and easy to test too, which is a nice way to kind of verify a chunk of our code for ourselves and others. So there is some value in making it a function, but if you think I would never have made that a function, you're normal. Okay, yeah, okay. Like I just said. You may think it's silly, perhaps you're right, but it's easy to confirm correctness. It's solving an important subproblem. It's facilitating our incremental development. And yeah, great. So I have a function to calculate the total kilometers driven. Just take the difference of the odometer readings. Now if I want to know the average kilometers driven a day, well, all right, for that, I would need to know the number of days and the total number of kilometers. So if I write a function that takes two parameters, number of days, number of kilometers, all I have to do is just do the average calculation. Just divide the total kilometers by the number of days. So you find out total kilometers per day. There, great. Another very simple function. Another function you might think to yourself, why would I make that a function? I could just write that one line of code. But again, it facilitates easy testing. There's value there. And it's solving an important incremental part of this whole problem we're trying to solve. Now, if I need to call kilometers above allowable average. Okay, so I'm going to have a function that's going to address this subproblem. I need to know how many kilometers were driven above the 100 kilometer an hour, the 100 kilometer a day allowance. All right, so all it's going to do is take average number of kilometers and it checks. If average number of kilometers is greater than 100, return the average number of kilometers minus 100. If that's not immediately clear, let's do an example. If I drove 101 kilometers, I'm only supposed to pay for that one extra kilometer. The 100 I got for free, or already paid for. So if it's 101, 101 is greater than 100. So I return 101 minus 100. Well, that just gives me the 1 over that 100. If it's not greater than 100, well, it's 0. If I drove 99 kilometers, how many, on average a day, how many kilometers did I drive above the 100 limit?
0.
None, right? I could have driven 0 kilometers in total. How many did I drive above the limit?
None.
None. 0. It's none. Yes?
In your dot strings, what's the at symbol for?
The at, that's a mistake. That should be colon.
Okay.
The at is, that's a good catch actually. If you're comfortable on GitHub, I'd recommend making at least an issue on that thing. But the at is just one of the conventions people follow in terms of like the docstring styles. The docstring style I've been using is the one with colons. But I guess in this example, is it all wrong? In this particular topic, the other convention was followed by me for whatever reason. Sometimes it's, depending on your programming environment, it'll auto-complete parts of your docstring for you, and maybe the autocomplete was set to the wrong version or something. Good catch though. I mean, very observant. Didn't even notice that. Who else noticed that? Well, you're the weird ones. Very observant. Well done. Okay. This right here. Okay, cool. So, remember when we talked about constants? No? Come on. True. Remember, the idea of constants are you have this variable that you set, and you set it, but you don't touch it. Right? You can use it, but you never change its value. There's nothing in Python stopping you from changing the value of a constant, but the spirit of a constant is you set its value and you leave it alone. And I showed you the example back when we talked about variables, the example of sales tax, right? The example with sales tax, let me go back real quick. Here. So if I had some calculation where I wanted to calculate some bill after sales tax, I would do, okay, 1045 times 1.15 for the total with 15% sales tax, right? This shouldn't scare anybody. That's how you do that calculation. But one of the problems here is, there might be a lot of lines of code in here in my program. These are 2 lines from a billion-line program doing a lot of sales tax calculations. If the government changes the sales tax value to 14%, I have to do a lot of find and replace, right? Kind of annoying. Maybe not that big of a deal, but it's extra work. But if it was set to a variable, well, I could just change the assignment to a variable and then use the variable, right? So now, all I have to do is go change this line to 1.14, and then all the other places in my code needing that sales tax calculation just recalls it from that variable. And here I would make it a constant because my program should not be changing the value of that variable. I will be the programmer when the government changes sales tax. I will be the one that goes in and changes that one line of code. Great. But it's a constant because the program isn't going to change the value of that variable. At least it shouldn't, right? And a convention for constants is to have all uppercase. And another really big value of this constant is it gives a name to the value. If I maybe the variable names gives you a good hint, but consider just seeing 10 like you were given a chunk of code. You have no context about what it's doing. And you see 1045 times 1.15. You're going to go, what's 1045? What's 1.15? What do those values mean? Those are just numbers. They're literals that have no meaning to you as a programmer reading that code. But if you consider the sales tax, if I see a line of code that says 10.45 times sales tax, oh, I know what that's doing because it's pretty darn obvious based on what the name of that constant is. So there's a lot of value in constants. There is a really good argument to be made that, maybe in this average kilometers function where I check if it's over 100, maybe I really shouldn't check if it's over 100. Maybe I should have some constant because it's possible maybe the rental company decides to make that limit 50 kilometers a day, right? So they might want to change it. And again, as a programmer, when I see greater than 100, sure, I've got a comment there describing it, but the code itself could be a little bit more descriptive. if it was called something like daily limit or something. What was the example I used here? Average daily limit. Great. It might make the code a little bit more better. So this might be a place to use a constant. I didn't here, but maybe you thought you could use a constant here and you'd be right. Any questions so far now about anything we've seen? See, we're solving a more complex problem, but you're hopefully seeing that as we break the problem down, solving each individual subproblem so far is stupidly simple. It's, oh, what's the difference between the odometer readers? Calculate the per day average. But they're only simple after we broke the problem down. We broke the problem into subproblems. The subproblems are simple. We can solve those. Great. So let's go revisit the calculate total charge. All right, reasonably, we have an idea what our parameters are going to want to be now. Number of days, age, rental code, odometer start, odometer finish. Great. The values that we read from input. Okay. So we've got our total charge equals 0. I can now fill in total kilometers traveled. Just call the function, total kilometers. Boom, have it. Average kilometers, call the function, have it. If it's rental code B, I know what if statements are. If the rental code is B, then the total charge is 20 bucks a day. And if you're wondering where I got that, that's from the description. 20 bucks a day plus 30 cents for the total kilometers traveled. That's it. Who here thinks, yeah, that's easy. Yeah, I guess. There you go. After it's broken down. Now let's think of the harder one. That weird one with D, with that 100 hour, Total charge is 50 bucks a day, plus 30 cents for every number kilometer above the average. Because I have a function that tells me how many kilometers above that limit. If I give it 101, it's going to return 1. 1 times 30 cents, and just add that to the total daily charge number. That's it. Now, when I say that's it, I'm not trivializing the problem. I'm trying to emphasize that we solved the subproblems. Suddenly, we use our solutions to solve the bigger problem. It's not too bad. But to re-emphasize, it's not supposed to be immediately clear. I worked through this example with you. You're going to get your assignment, and you might be kind of put in the situation. It's not going to be obvious to you what the subproblems are. It's not going to be obvious what those solutions are sometimes. And it's not going to be obvious how to use the solutions to the subproblems to solve the bigger problems. Your first assignment has a lot of description to help you along, but as you go forward, that's not going to be the case. This might seem simple. Oh yeah, I got it. Well, no, I went through this with you. And by taking your time, you can see how it works. But, it's just one example of a lot of problems that need solving. Oh, and then I have that if age is greater than 25, add 10 bucks a day. Who here has ever seen this before? No one. 1 person. Good. 2 people. This is super fancy programmer syntax for total charge equals total charge plus 10 times number of days. Let me write it out. Let's say I have 10. And then I say, when I hit run, what value should I expect to see? Yellow. 20. Why? Some variable is set to 10. Next calculation, well, I take the value of some variable, it's 10, add 10 to it, okay, now I have 20, and then I put it into the variable some variable, which happened to be the same variable it came from. It just overwrites what was in there before. Print it out. This syntax is very common in programming. As you go forward, you're going to see a lot of ways to just add some value to some variable that you want to hold on to. It's so common we have a short form for it where we just say some variable plus equals 10. It's going to do the same thing. I'll make this 100 to show you that, it's different values. It's just a shorthand for some variable equals some variable plus 10. That's all. If you don't like it, you don't have to use it. The story I heard, I don't know how true this is, it might be apocryphal, but the story I heard about why it exists is if you go back decades ago, the computer monitors were really crappy, and you could only fit so many characters in a line. And if you had a variable name that was kind of long, like some variable isn't short, if we go back, that's how many characters we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. There's 34 different letters on that line, right? That's a lot. And if my monitor can only show 15, I've got a problem. So something like this is a way to cut down how long those lines are. I don't know how true that story is, but it sounds believable to me. So that's all the plus equals means. What do you think times equal does? It's not a trick question.
Same thing, but you're multiplying.
Yeah. Take the value, multiply it by 10. So 10 times 10, store it in some variable. What do you think minus equals means? Same thing. What do you think divide equals means? We get 1. Oh, I guess it does division. What do you think mod equals does? I'm going to be honest. I never used that before in my life, and I didn't know what it was going to do. I figured if it was going to do anything, it would do that. But I didn't know if that syntax would even work. But how about that? Cool. It's kind of neat. I would never have thought to use it. For some reason, it came to me right now. Yes?
Can you use exponents and also if you import math, can you use those as well, or is that pushing it a bit?
Well, it looks like you can use exponents,
Okay.
which again, I didn't.
Yeah.
I just did it right now. The functions are going to be a little different.
Yeah.
Functions are different. These are operators when we have fancy syntax,
Okay.
but there's ways to use functions even way better than operators that we're not going to learn. Yes?
Do you know if it's possible to use some of the math functions with it, like math.square?
No, but there are ways to do similar things with the functions that are different than this, that are, just to answer what he said too, because he asked kind of the same question. The way you would do it is way cooler and better, but we're not going to learn it in this course because it's a little complex. Cool question though, nonetheless. So that's what plus equals does. If you find it more obvious to write out the whole thing, some value equals some value plus 10, by all means do it. Both are fine. And I wrote a bunch of assert tests just to make sure it seems to be working correctly. Cool. The trick here is, if I went over this solution and you followed along and you're like, yep, makes total sense, or if you followed along and you're like, yeah, I kind of get it, or if you follow along and you're like, yeah, I don't know. It doesn't matter. Go back over this stuff, take your time, and understand it. It might seem like, yeah, all these things are so trivial, but they were only trivial after going through the exercise of breaking the problem down. Which maybe I didn't impress upon you enough with this example about how much of this process was breaking the problem down. That's a big part of it. But once you break it down to those small subproblems, then you can start constructing your solution. This was a top-down approach where it was problem, break it down, solve these problems to solve the big problem. Maybe it should be called a top-down, bottom-up approach because it's both. Great. There is nothing stopping us from writing a function to calculate the age calculation. If you feel that'd be better, then I would encourage you to do so again, assuming you implement whatever. I'm just giving you a bunch of examples. whatever. Any questions about any of all that? Yes.
Is it better to do the input in one line and then split it into separate, like split the list, or it does the same thing?
It's arbitrary. The way doing it here allowed me, for the example, if I could find it.
Like I guess it more applies for like caddis problems, I guess.
Yeah, the input again is only a way for demonstrating this particular one.
Yeah.
Usually in general, like on the assignments you will never be at, well, that's not true. On assignment 3 you will. It's very rare that you actually use input like you do in these that we've been doing for caddis, just in programming in general. But at this stage, it's kind of nice to be able to interact with your programs with input. And your question about, if I can find the chunk. Here. Like, oh, why didn't I do it on one line? I mean, I could have, but now, you know, with the text description, it's kind of nice, but it's all arbitrary. The important part of it was this function, right?
Yeah.
Other questions? All right. Yes. Say that again? Yeah, I don't know yet. I'll announce it once we have a sense of when we want to have the midterm. It'll be based on how far we get. It'll be around reading week, maybe before, maybe after.